Look at solving differential equations. So what we are looking at is second order homogeneous equations. So let's try to look at this one together. Number 9. Y double prime minus 4y prime plus 13y equal to 0. So in this case, first thing which we have to do is we have to find the characteristic equation. In our case, it would be r squared minus 4r plus 13 equal to 0. Of course, you can easily figure out the value of r here. What I'm thinking about doing is subtracting 9, so we get r squared minus 4r plus 4 equals negative 9. In this way, we get to have r minus 2 squared equals negative 9. So then you can see that r should be equal to 2 plus or minus 3i. All right, so knowing this one, let me minimize this now. This will help us to figure out the our solutions here. Then basically what we end up getting is, yes, we end up getting e to the y equals c1 and e to the 2 plus 3i x, and then second one will be plus c sub 2 e to the 2 minus 3i x, and then of course we can factor out e to the 2x. That's the common factor here. Then we get e to the 2x, and we have c sub 1 e to the 3i x, and then plus c sub 2 e to the negative 3ix. Now, then as we talked about it in previous question, this can be written as sine and cosine. So in other words, what we end up getting is y equals e to the 2x and c sub 3 cosine of 3x plus c sub 4 sine 3x. That's what we end up getting. Alrighty, let's move on to the next question. So in this case, we have our characteristic equation between 2r squared plus 2r minus 1 equal to 0. In this case, it's not factorable. Why don't I just use the quadratic formula here? So then r will be equal to negative 2 plus or minus square root of 4 minus 4 times a becomes 2 and c becomes negative 1 all over 4. Now let's try to simplify this one. Then we get negative 2 plus or minus, so this becomes 8 and then positive, so square root of 12 over 4. Then you can easily see that this can be simplified in a way that we get negative 1 plus or minus square root of 3 over 2. So what I can do is I can rewrite this one as y equals c sub 1 times e to the negative 1 plus radical 3 over 2x plus c sub 2 e to the negative 1 minus radical 3 over 2x. And then in this case, even if I were to factor out e to the negative 1/2 x, it doesn't really benefit that much. So I can just leave them as in this way. All right. So let's look at the next question here. How about number 13? So in case of number 13, you can see that my characteristic equation would be 100 r squared plus 200 r and then plus 101 equal to 0. Oh, actually, in the previous questions, everything was in terms of t. Sorry, so I'm going to change that in terms of t, not instead of x. Because in terms of t, let me check the previous question. Oh, it didn't really matter. So, all right. Now, then in this case, we can try to. What we can do is we can. In this case, we probably have to use the completing the square method. How about that? So what I'm going to do is I'm gonna subtract 1, so I get 100 r squared plus, because this one looks so close to perfect square, plus 100 equals -1, and I'm gonna divide the whole thing by 100. Then I get r squared plus 2r plus 1 equals -1 over 100. Now, then in this case, we know that r plus 1 squared is equal to -1 over 100. That gets us r equals -1 plus or minus 1 over 10i. That's what I'm getting. So let me minimize this one a little bit. All right. So my equation would be now then p equals c sub 1 e to the -1 plus 1 over 10 I x, and then plus c sub 2 e to the -1 minus 1 over 10 I, actually not x, but t rather in this case, because we have the t on the bottom, t here. But then you get to realize that e to the -t power can be factored out. So e to the -t can be factored, and then everything is complex exponent. So therefore, or imaginary exponent. So I'm going to convert this one into sine and cosine. So we get c sub 3 cosine of 1 over 10 t plus c sub 4 sine of 1 over 10 t. That's what p is equal to. All right. So with that one, we are done, and I'll see you later.